नमस्कार. अंतरिक्ष अप एंड अवेत सगळ्यांक येवकार. आमी फाटल्या एपिसोडांनी पळयलें की मनशान जेन्ना आकाशा कडेन पळयलें, आमच्या आदी मानवांनी आकाशा कडेन पळोवन, आकाशाची नक्षत्रां पळोवन ताणें खूब कितें कितें नवें शिकपाक सुरवात केली. एस्ट्रोनॉमीन आमकां कालगणना दिली, मनीस वेळ वळखुपाक शिकलो, कॅलेंडरां करपाक लागलो, चंद्राची गती वयल्यान मनशान खूब कितें कितें शिकलें, कॅलेंडर केलें, पंचांग रचलें, अशें खूब कितें कितें एप्लिकेशन्स एस्ट्रोनॉमीन आमच्या डे टू डे लायफाक दिल्ले आसा. सगळ्यान एक इम्पॉर्टंट अशें आमी एप्लिकेशन म्हणूंक शकतात मिटिओरोलॉजी. मिटिओरोलॉजी म्हणजे स्टडी ऑफ वेदर, क्लायमेट, एनवायरमेंट, हें सगळें जें आमच्या वातावरणा बद्दल जें विज्ञान आसा हाका इंग्लिशेन मिटिओरोलॉजी अशें म्हणटात. आकाशा कडेन मनीस पळोवपाक लागलो, नक्षत्रां वयल्यान कितलो पावस पडटलो, ऋतू कशे बदलतले, सूर्य चंद्राची गती कशी आमच्या कॅलेंडराक इन्फ्लुएन्स करता, हें सगळें मनशान वळखुपाक सुरवात केली. आतां हे मेट्रोलॉजी जी आसा म्हणजे वेदर सायन्स एक खूब एक तरेन कॉम्प्लिकेटेड अशें विज्ञान आसा. आतां ते एस्ट्रोनॉमी कडल्यान भायर सरून एक कंप्लीट ब्रांच मेट्रोलॉजी ही सायन्साची एक ब्रांच जाल्ली आसा. आमी ती आज शिकपाक आयिल्ले आसात. हांव आसा पणजे आल्तिनो हांगा आनी हांव आयला इंडिया मेट्रोलॉजिकल डिपार्टमेंट म्हणजे भारत मौसम विज्ञान विभाग आमचे मेट्रोलॉजिकल डिपार्टमेंटान आयिल्लो आसा. आनी थंय आमी आज मनीस वेदर कशें वळखता, कशें कशें विज्ञान, कशें कशें सायन्स वापरून आमी आमचो हवामान, आमचें वातावरण, आमचें क्लायमेट हाजी सगळी आमी स्टडी करतात ते आमी पळोवन घेतले. येयात म्हजे बरोबर. आमी आसात इंडिया मेट्रोलॉजिकल डिपार्टमेंटाच्या डायरेक्टराच्या कॅबिनान. डायरेक्टर आसात श्री के.व्ही. सिंग. श्री के.व्ही. सिंग सर हे म्हाका दिसता गोंयकारांचे परिचितूच आसतले. प्रत्येक पावस लागीं आयलो, पावसाळ लागीं आयली किंवा कितें सैमीक घटना घडली जाल्यार तांचे स्टेटमेंट्स प्रत्येक पेपरान येतात, इंटरव्यू दितात, ते स्टेटमेंट दितात टीव्हीचेर, पावस कसो पडपाचो आसा. तर आमी येवकार करुया आमच्या प्रोग्रामान श्री के.व्ही. सिंग हांचो. गुड आफ्टरनून सर. दिस प्रोग्राम इज अबाउट एस्ट्रोनॉमी. And I always read that astronomy has a lot of connection to meteorology. Meteorology is a very important part of our life, and I think your answers will give a lot of importance and highlight different difficulties and misunderstandings about the weather and meteorology that our viewers have. What exactly is the meaning of meteorology? इसका मतलब क्या है?
Namaskar. See, meteorology which gives the study of this atmosphere. Actually, because every event of this weather, these are generated in this atmosphere only. So जितनी भी हमारी घटनाएं हैं वेदर से संबंधित सभी एटमॉस्फेयर में ही उत्पन्न होती हैं. So this is the study of this actually. So there are so many factors which we deal with this meteorology. Atmospheric pressure is there, wind is there, temperature, humidity. So there are so many parameters.
So these are all related to meteorology directly.
Yeah.
So and there are some other factors also like I think earthquakes and all, which also you all keep a watch on.
Yeah, earthquake we are keeping a watch. Only thing because for earthquakes there is no forecast so far. हम इसका प्रेडिक्शन एडवांस में नहीं कर सकते हैं, अभी तक ऐसा टेक्निक अभी उजागर नहीं हुआ है. लेकिन कहाँ कहाँ अर्थक्वेक हो रहे हैं वो रिकॉर्ड होते हैं और उसके बेस पर फिर एक नेटवर्क तैयार होता है कि भाई कहाँ कहाँ जोन जो हैं वो डाटा कलेक्ट होता है और एक नेटवर्क के थ्रू कहाँ डेंजर जोन है, कहाँ पर जोन, इस तरह से जोन में डिवाइड हुए हैं. फिर वो जोन 2, जोन 3, जोन 4 लाइक दैट.
Can you tell us briefly what is the history of Goa Meteorological Department?
See, this office earlier it was known as Servico Meteorologico do Estado da India. It was under Servico Meteorologico Nacional, Lisboa, Portugal, which was established in Portugal at Lisboa. Lisboa. It was on 29th of August 1946. So this meteorological services in Goa was started just after it started in Portugal. After that, after liberation of this Goa liberation, this in 1961. After that, this department came under this India Meteorological Department, and it was known as Goa Observatory, Goa Vedashala. So now recently in 2007, it is declared as Meteorological Center Goa, Mosam Kendra Goa.
The Portuguese time, the meteorological department, and now in the modern time, is there any difference?
See, earlier actually this type of equipments, this latest technology was not there. But still that this department was working there, but these our equipments like thermometers, wind vane, this many these parameters already it was there. These techniques were there.
During the old times also daily prediction was done.
Not here, prediction was not there. Only observatory was there. They were recording observations. So this surface observation. Only surface observatory was there. Later here upper air observatory came. Then it came seismology came. So slowly this units were opened there.
Meteorological department people are identifying with monsoons because that is the most important part of our life. So how do you predict monsoons in the meteorological department? What factors do you use here?
See, for monsoon actually as far as monsoon is concerned, actually if we see from this weather parameters, this four season this we divide all this all year. That is winter season, after that summer season, then it comes monsoon season. So here we deal with this southwest monsoon season, June to September. After that post monsoon season comes. So actually what is monsoon? Monsoon is the mostly this is a reversal of wind.
Reversal of wind.
Reversal of wind actually. What happens in the summer season? This earth heats up, and this low pressure area develops. So for this development, this wind comes from the high pressure zone to the low pressure zone. So that's why these winds are changed to southwesterlies. So that's why it is called the southwest monsoon season.
Monsoons are seasonal winds that bring heavy rains in the summer and dry conditions in the winter. This phenomenon is in response to differential air temperatures over the land and sea. The areas mainly affected are India, Bangladesh, and its surrounding East Asian countries. To a lesser extent, Central Africa and Northern Australia are also affected.
The direction the wind system travels is reversed in the winter and summer months. The winds travel from land outwards to the sea in winters, and in summers from the sea inwards to land. In winter, land is cooler than the ocean in the northern hemisphere. This leads to the rising of air over water and sinking over land. As a result, a high-pressure system is created over land, which ultimately results in dry conditions. In summer, the opposite occurs. Land is warmer than the ocean, which results in the air above the land to rise and sink over the water. This creates a low-pressure system over land. As a result, warm, moist air is carried over the ocean inland, where it precipitates out, leading to the massive amounts of precipitation experienced.
And we use the satellite picture also. Mostly satellite picture is very much used. And we take the surface observations, this upper air observations. Surface observations are plotted on a chart, and we analysis of that. Statistics, yeah. All the observations throughout the India, we take surface observation 8 times in a day.
8 times a day.
24 hours. After 3 hourly observation, it is taken.
So the meteorological department is not closed as such; it is always functioning.
This is an operational department. 24 hours these observations are there. After 3 hours, surface observations are taken, and it is means this all over country, sorry, all over the world, because observations are taken at the same time. That is in GMT timings. So this 3 GMT means 8:30 in the morning, then 6 GMT, 9 GMT. So all over the world, this time is fixed as per on the GMT timing. Same time observations are taken, and it is sent to all over the country, all over the world.
Sir, you just now spoke about satellite. For us also in astronomy, satellite is an important topic. So are you connected in Goa, sir, to a satellite, or how it is?
See, we have our satellite meteorologists, and we have headquarters New Delhi.
So New Delhi is connected?
New Delhi. That New Delhi is connected. There, actually, we have the big headquarters there. That is connected with the satellites. So this satellite pictures we are getting on our internet, on our website also we are getting daily. So through that satellite pictures we are making our predictions. What is the position of, where are the clouds, where are the if any system is generating some low pressure area, some the cyclone like that. So we are predicting on this base of the satellites.
It is the need of the hour to find out and understand the characteristics of the water cycle and the parameters that affect it, and obtain significant statistics for analysis. As we all know, the water cycle in general is driven by the thermal energy received from the sun. The exchange of this energy among the oceans, the land and the atmosphere controls global climate. Tropical areas receive most of the sun's energy and send water into the atmosphere by the process of evaporation. However, at present, we have limited scientific understanding of the global and local parameters and processes which affect the water cycle. Because of this, we are not able to have clarity in our predictions about climatic events like cyclones, monsoons, floods, or droughts in the tropical zone. A unique Indo-French scientific megatropic satellite has been developed specifically for atmospheric research. The data collected by the satellite will allow us to improve our knowledge of the contribution of the water cycle to climate dynamics in the tropical atmosphere, as well as increase scientific understanding of the process linked to tropical convection. This knowledge will enable us to predict short-term and long-term weather with a greater measure of certainty. After the satellite was fully integrated at Isaac, it went through a series of further laboratory and environmental tests and was finally flagged off for SDSC Shard. The existing network of ISTRAC ground stations, along with support from agencies of other nations, will track and communicate with Megatropic under the control of Spacecraft Control Center SCC at ISTRAC, Bangalore.
The data of Megatropic are now weighted impatiently by all the scientific communities about meteo and climate, because we need to measure all around the world and with repeated measurements. So we need several satellites. And so Megatropic and GPM mission will join to be one constellation, bringing new data, very precious, to the scientific communities.
Megatropics, a bilateral mission between ISRO and CNES, marks the availability of a unique combination of sensors.
We have two type of monsoon here in India. This main monsoon is the southwest monsoon. So for that, about 80% of rainfall is received through this cyclone, so through this monsoon actually. Other one is the northeast monsoon season. So after October, when this monsoon is, the southwest monsoon is withdrawn, after that the northeast monsoon is, that gives rain for the south. This Tamil Nadu and some northeast India also it gets rain.
There are so many natural disasters. So what type of disasters approximately, like how you can warn people? How do you do that? How do you warn people?
See, these disasters which are connected with the weather calamities, weather disasters.
Cyclones.
Main is the cyclone and tsunami. So cyclones, actually our departments, for as far as cyclones are concerned, 100% we are predicting.
Yes, correct.
So because from this, if any low pressure area generates in the sea, from that time only we keep a watch. Low pressure area is developed, then it becomes a depression, then deep depression, then cyclone, severe cyclone, like that. So we have a track completely. So we have complete watch for the cyclone, and we give early warning, means warning start from when depression is, it is developed as a depression.
Okay.
From that time we start giving the warning.
So what about tsunami and such things like that?
See, tsunami is a very vast system which gives this sea waves. So it is very dangerous for the coastal areas. So for that tsunami also we have this watch on that. Yeah.